Thank you for coming back in. I only have one intro slide. I do want to mention one thing. If you wanted to get to the agenda on our Google Docs, it was sent in the Slack for Biocuration, but Alan kindly put it up on the left-hand side. That said, the small URL is up on the far left. So if you want to get to the Google Doc, we'll also send it out through the Biocuration channel after this meeting. So I know we're only talking for a few short hours this morning. I think it's been super productive, great conversations. We'll continue the same vein from the mapping between resources perspective. So again, to introduce myself, Lynn Schriml, I'm the PI for the Human Disease Ontology. When Sue and I were really thinking about this, we thought about all the years of connecting data, trying to really get resources to be aligned. And so for me and our project, we certainly think a lot about how we can use machine learning tools. We think about how we connect data, how it's not always such an easy one-to-one connection. There's a lot of things you have to think about when you're thinking about human disease and how it's connecting over resources and over time. And certainly machine learnings bring lots of opportunities to do so. There's a seat right there for you. Perfect. No worries. Okay, so I'm going to get right on to our panelists, and we'll go straight up to the hour, and we will go through, have introductions first, and then we are going to go through the questions. So the questions are here behind you for the first set of them. And they're also on the monitor in front of you for the speaker. And please start introducing, and I'm going to come join you.
Sure. I'm Harry Caufield from Berkeley Lab. So I'm a data scientist there and primarily focused on data integration and data mining, but in a more specific sense, that often means building knowledge graphs out of all that integrated data and trying to do machine learning on those graphs and see what we can learn about the relationships within. Lately, that also means trying to do a little bit more NLP with the help of large language models, and I'll probably cover a little bit more of that shortly. But I work in Chris's group at Berkeley Lab, so I'm not going to cover everything that we do. I'm sure that he'll be able to cover some of that as well.
My name is Alan Barron. I work with Lynn on the Human Disease Ontology, and we haven't applied so many machine learning things, but we've explored a lot of different approaches for mapping between resources, and some of those include previous machine learning approaches, and talked with a lot of groups. So my experience is more in exploration of the output of those and their quality and limitations.
I'm Chris Mungall, Berkeley Lab. I'm a PI on the Gene Ontology project. I also work on a number of other different ontologies. And so working in ontologies, I'm obviously very interested in mapping, between obo ontologies and between obo ontologies and things that are, not within obo. I'm very interested in standards for mappings, because unless we can actually clearly state what a mapping means, then we don't have any hope of having kind of high quality kind of like training data to improve mapping. So on that topic, we had a very successful SESAM workshop here in this room yesterday. So this is the simple standard for sharing ontology mappings, which is very relevant to our efforts here. And I think more broadly, I'm very interested in bringing ontologies and knowledge into machine learning processes. So in the past, that's looked like things like our Boomer algorithm, which kind of tied together ontology reasoning and kind of like probabilistic inference to find optimal sets of mappings, given a kind of like a big kind of confusing hairball of mapping. So we've used this for diseases and also for kind of like tasks like mapping Go to the RHEA database and the EC. And like many of us, more recently I've become very interested in large language models and how they can assist us in a pretty huge number of different tasks.
Hiya, I'm Jane Lomax from SciBite. We're a software company based in the UK, and we work in the sort of ontology space. So we build tools to, basically our customers are large pharma organizations who are trying to deploy fair infrastructures, and we sort of build tools that sort of help them with that. So ontology management, named entity recognition, all those sorts of things. But we've also recently released a mapping tool that uses the, how do you say it? System. We don't know how to pronounce it. It uses that standard. So we're kind of very much in that space. While quite a lot of our stuff is rule-based, so our NER is pretty much, you know, the sort of fundamentally it's rule-based, and we put a lot of curation into making that so it works well. And with a lot of the challenges that we heard discussed in the last panel. But we are exploring how we use machine learning. I mean, we've used machine learning for a fairly long time. So we use it for NER where rule-based doesn't work, where there isn't an ontology, or where new things are arising very quickly, like new drugs or new companies, where an ontology isn't there, so you can't use it. Or for things where the language is very complicated, like genetic variations, we use transformer models like BioBERT to sort of create specific models for that, for that NER purpose. But we're also experimenting with models in other places. So there's an embargo in most big companies, I think, on using ChatGPT for most things. But when we were allowed to use it, we were using it for question answering. So I think the key thing for machine learning in our industry is for it to be explicable. So if you get an answer, you need to know where it's come from. So using the LLM to do the natural language part. So you get the ChatGPT to write you the structured query that then goes to the database and uses the ontology-based query, and then comes back and gives you a natural language answer. So in that kind of place. So sorry, that was a very long intro.
Which of the topics you guys have to talk about first?
I don't know. Where do you want to start, Chris?
We could just,
Yeah.
I think
So I guess, So I've just given an example. So I think for us, because they're generative, right? And they don't understand science. They just, they use language, and they do that very, very well. So we're using it in places where, you need to be able to pivot between human language and something that's a bit more structured. But it's quite hard to figure out where they fit in.
yeah. Do you want to go next, Harry? Or?
Sure. Yeah. On that.
we have two microphones too.
Handy. So one of the things that I know we noticed going in, like when ChatGPT first started becoming popular, was the same issue that came up in the last panel, that, okay, it's really great at hallucinating IDs or making IDs that look functional, or even just, completely nonsensical. And on the one hand, there may yet be a use for that, or maybe just kind of like exploring the potential space of, similar terms. Like if you're looking at your term space, there's going to be, terms that are kind of in between others. I mean, in the sense of text, not in the sense of the identifiers, which the language models are also perfectly happy to hallucinate. But we, and by we I say Chris was certainly the originator of this idea, but we've taken it in a number of different directions at this point, of this approach where we use the language model for kind of the initial parsing and the annotation of a segment of text, but then we actually try to ground the terms in a given set of ontologies, just to actually ensure that we can yield a structured output that is as linked as we can reasonably get it, and grounded in those ontologies. So that it does change our perspective on it a little bit, because it becomes a problem less of, we don't know what our output from this is going to look like, and more of, you know, how can we better tune our queries and the set of domain knowledge that we're using to kind of link these identifiers in a meaningful way. And, you know, again, we're leveraging a lot of the resources that are out there in the process of using these really powerful models.
I was just going to say, since we're talking about ChatGPT, I don't think I've explored it quite as much as Chris, but I think that its real strength is actually in helping to, you know, in the previous panel, there was a discussion about, there's a lot of discussion about feedback and decreasing like the difficulties, like getting that as part of people's workflow. And I think one of the potential uses for ChatGPT is really making it more accessible to more people. You know, you don't have, it's so flexible. So if we could, you know, find ways to, I mean, do sort of what Harry described, you know, grounding these in true ontology terms of the ChatGPT, we could really, you know, allow people to find ontology terms more easily and structured vocabularies. We could allow people to report, you know, terms that they're missing more easily, you know, terms that, so I think in the sense of making it more accessible to the general world, like, you know, what it does well, that language, sort of that natural language is probably where it's going to be most beneficial to us, but there are a lot of possible applications, I think. And so I look forward to seeing that, although I'm a little bit concerned since, you know, these models are mostly trained by private companies as to what access we'll actually have to them and being able to use them. So we'll have to see how that plays out. And I think it's going to be a while before we get good access to them, if we get access to them. Just because, you know, because of where they're being trained and how much they cost and what they're going to be applying to them. So,
yeah, I think that's a big thing, actually, the security issue, because at the moment, you know, it's just out there and everyone can play with it, and, you know, you see all these potential, like, you know, applications, but actually in reality, no one's going to really want to put anything precious, especially for like companies where you've got secure data. You know, you don't really want to put it out in the cloud where who knows what's going to, or your competitors using it to train their own model. So yeah.
Yeah, I really, just to echo that, I think, you know, I'm a big proponent of these large language models, but it really does trouble me how, you know, the most powerful ones right now are, you know, companies like OpenAI, who, despite their name, are not open. It is very much closed, and it's, you know, it's not clear exactly what they used for training. You know, it could very well involve lots of kind of like toxic, you know, information and kind of like misinformation and so on. And there's also the environmental costs in training these large language models. But, you know, I am, you know, heartened by some recent results showing that it's actually going to be possible to get some of the power of something like ChatGPT using kind of like open models like kind of, you know, Alpaca, Vicuna, and things like that. But right now, to get the full power of these, you know, we essentially have to use some of these, you know, existing kind of like companies like OpenAI.
Are you hearing, Chris, or any of the panelists about any public efforts or like governmental efforts to get this into our, like NIH, think of, or National the Health Service in the UK? So is there anything about that conversation? Because certainly it sounds like we need a public large language model from our perspective as, you know, biocurators and data handlers.
Yeah, I very much, yeah, I think that's a great point. I'm not aware of anything happening at the agency level. I think there should be. I think NIH should be pushing on this. But
how about a white paper from all of us,
mm-hmm.
maybe?
Mm-hmm. But there's certainly a lot of kind of ground up efforts with just a lot of groups kind of like figuring out ways to kind of like do the same things, but with, you know, now there's actual models that you can actually run on a kind of like commodity, kind of like, yeah, Max GPUs and things like that. It's getting there.
Yeah, I suspect, at least from the, obviously I can't speak on behalf of the NIH, but I'd suspect that there's going to be a lot of suspicion for a while, a lot of skepticism from funders, not just based on, you know, their general skepticism towards emerging ML approaches, and rightfully so, but I think, yeah, this is especially one case where it's very easy to have obfuscated data. Like even if it is open, even if you are very clear, hey, this is what we trained it with. Yeah, I think it's very easy to have sensitive or privacy protected data leak into that data set.
I just wanted to comment, we recently have a workshop, at Uniprot organized workshop where we invited founders from ODSS, and the workshop was about machine learning, and we talk about the large language models and everything. So there is a group, an active group working on AI ML ethics on things related to this thing. So there is actually very a lot of activity ongoing, so they are aware of it. And actually, from the Uniprot's perspective, they're asking us to explore all these methods. So they are interested, yeah, and they are looking.
Yeah, I think there's some question as well, like whether having one model to rule them all, having this massive expensive model is actually that valuable anyway. And because actually the bigger it gets and the more like diverse the stuff you put into it, like more black boxy it becomes and you don't know why it's giving you the answers. Whereas, you know, for science, I think often what you want is a more targeted model that's much quicker to train and much easier to understand how you've got the results you have.
So one burning question as a biocurator for all these years, I think it was brought up in the earlier session, we have all these new publications and new data sets coming out. We have new terms needed. I think it's an ongoing issue. How do we get those requests to the vocabulary developers? How do we identify when a chemical name is changed? Like how do we stop that area of the bottleneck from data generation to getting it into systems so it can be used for annotations? Thoughts for biocuration to machine learning options for that from the panel?
So this is like getting new ontology terms.
Yeah, I think it's from making the connections between the data and actually people that need the terms and to make sure they get fulfilled. That kind of, I don't think we've ever solved it. We have trackers for various ontologies, but we don't really have a system to kind of help gatekeep maybe or help communicate.
Yeah, so we've done a bit of work around sort of automated ontology building with machine learning, and Rebecca's going to do a talk later on in the conference about that in a bit more detail. But yeah, you know, and it's possible. I think, you know, we're always very keen to make sure that, you know, because ontologies are, you know, they need to be human. They're human constructs, but you can give you a good starting point, right? And so, you know, you could, and we've been able to sort of fairly quickly pull up, you know, new ontologies or find missing stuff from ontologies. And you could see a way where you could have this sort of a candidate term pool. You could sort of assign IDs. I guess it's the infrastructure bit you need to build, right? It's the kind of, you know, how do you then dole that out to all the individual groups? So.
Yeah, I think there's some maybe simple things we could be doing as well, like I was saying earlier, just better kind of like flow of information between the text mining community and the ontology community. I suspect there's a lot of redundant work going on in terms of building dictionaries. So the NLP people will go off and kind of like build a dictionary when the ontology people are also adding synonyms into their ontology. Maybe those things should be just combined and we should just kind of like centralize that task. Yeah, and there's this kind of constant challenge of kind of like people say, oh, the ontologies are behind, you know, they're not adding my new terms in there. And we're coming up with better tools. Like I think a lot of ontologies now, if they're using something like the ontology development kit, is very much easier to use tools like Robot and DOSDP to get terms in more quickly, to do it based on kind of simple spreadsheets, which biologists prefer rather than going into a kind of specialist tool like Protégé. So I think we are getting better at that kind of rapid turnover of getting new terms in, but we also have to be careful sometimes. If you go too quickly and just take everyone's terms, it creates a kind of like a legacy that is actually, you know, hard to maintain. So we had this experience in Go 10 years ago where we had a system to make it really easy for people to just dump their terms in there. And after a while, we looked at some of the annotations, we realized that a lot of these were not particularly high quality, and it wasn't really in scope for the ontology. And it was actually kind of more work to kind of like back some of these things out. So I think we have to be careful at the same time. And just also on the topic of kind of like making it easier to kind of like, add terms into ontologies, going back to the language models topics, we've been doing some experiments using GitHub Copilot, which is a tool currently only used really by software developers. And it's essentially kind of autocomplete on steroids, and it uses a large language model to basically help you kind of like type out code more quickly. But it actually turns out to be really good for, authoring kind of ontologies quite quickly. If you're careful about the ID hallucination problem, it's actually, quite interesting how well that works.
Right. Lynn, I have a couple questions or a couple comments from Susheta online, one of the panelists who was unable to make it today. I will attempt to read these, and then y'all can interpret them for me, because it's definitely getting, so her first was that evaluation is very important for this area because it is so challenging. In the earlier session, we had the comment that for some recalls or for some it is precision. And she says, as a machine learning natural language scientist, one can ask, can we also compute the agreement among the curators before using that data to the machine learning models? Like, is it the case for NLP apps so that we understand how to use machines for a specific problem? And then her second comment, which I think is more related to what we were just talking about, is a whole ontology can be interpreted or flattened to use that in a machine learning model. So dividing a big ML task into a pipeline with small models would be useful.
Yes.
Yeah, this is just comments from.
So I think this also touches on, I think of it as trust but verify as a biocurator using entity recognition or machine learning tools. How do we communicate our level of trust but verify? What does that mean to us, and what does it mean to the machine learning community?
Yeah, and I definitely agree with that. But yeah, also I think really all the metrics of even just like inter-annotator agreement or just any kind of alignment between expectations versus actual output, is going to be informative in the long run, possibly even more informative than any F score is likely to be. Because I think one thing that we've seen, and not even just with the large language models, but with a variety of different NLP approaches, is okay. I mean, this is designed, under very specific conditions of like, okay, we're just using this for NER. But then if you realize, oh, okay, well, these extracted entities actually contribute to, maybe we want to build a topic model of an abstract, and it turns out, that's a case where, maybe recall doesn't matter, then I think you start to see a lot of the same use case differences that we heard about in the first panel as well.
Yeah, I mean, I think the way that we sort of see it is, the models are a kind of curator aid more than anything else. And so if you are building ontologies, they have to be human validated. That's why they're valuable, and that's why they're useful. But you can do some of the easy stuff using models like writing definitions, predicting relationships, finding synonyms, that kind of thing. As long as it's then validated by a human, I don't see why you need to. I mean, I think if you're going to, maybe, I guess for NER models, you have, there's less validation, but I still think, having a human in the loop is critical for those things.
Yeah, and I think just having kind of like systems that make it easier to have humans in the loop. I mean, I think there's a tendency with machine learning people to essentially, focus on leaderboards and just kind of like throw some results over the wall and say, hope this is useful for you. But I think you know, in order to kind of like efficiently evaluate these things, we need better kind of like curation systems like the one, you know, Valeria mentioned, you know, earlier, being developed at the Alliance of Genome Resources, that just make it kind of like easier for curators to kind of like consume these things. And then the cost of having something that is maybe, you know, it gives you a suggestion, but maybe it's kind of obviously wrong, and you just quickly move on to the next one. And I think that's something that the, again, going back to Copilot, that they did very nicely. They really focused on the user experience there. And to me, it doesn't matter that often a lot of the suggestions they give me are not quite right, because it's a very efficient system that I can kind of like quickly cycle through the different possibilities. And I think there needs to be more emphasis on that human in the loop aspect of it.
So I'm going to ask,
Go for it.
actually, I want to ask Alan about maybe give some insight into his work with biomappings and that kind of feedback loop, because anyways, maybe you could talk about that. What the work they're doing.
Oh, well, I mean, I don't know the details of that. We'd actually have to ask Charlie how that particular biomapping specifically exactly works. All I know is that it creates a score, and I haven't looked into how they create that score. It's mostly lexical matching and grounding, like Harry was talking about. But you know, since we're talking about mappings and sort of like, you know, we've talked some, I think, about how people use mappings in you know, NOP, or how people use ontologies. Like even mapping between ontologies can be an extreme challenge. You know, there are a number of people who have tried to create different models, machine learning models, rule-based models, all kinds of models to map between, you know, disease ontologies and things like that. And part of the problem with that is just they're made for different purposes, many of them. And so how you interpret them is context-based. So, you know, I mean, at a conference that I was at back in December, I was talking with someone who does FIWAS, and about how, you know, she doesn't trust fully any full human curated resource because she's dealing with ICD codes. And, you know, you put an ICD code in, but it's not like every ICD code you find in an EHR means they have this disease. It just means they wanted to charge for that disease, right? So there are issues with use of curated resources, and you sort of have to think about who your, you know, user base is and how they're going to use it. I think that's the one thing that machine learning things could add is some flexibility in those contexts, but we don't have a system for that right now that exists, like to give end users that sort of flexibility. So, but I think, you know, both the upfront and back end of, like, you know, these ontologies and other structured vocabularies and things like that, all of it could really benefit from some machine learning, because nobody can keep up with it. You know, like if you just look, you know, at the disease space where I work in, stuff's changing way more than people realize all the time. And, you know, like different resources change at, you know, they have different release timeframes and updates, and no human can keep track of it all.
Yeah, no, I totally agree on that, on the mappings, that the hard thing isn't doing the actual mapping. It's like, what's the mapping for, and is it safe to map under those circumstances, and what qualifications you need to add? And so it's just like a set of decisions you have to make. And actually doing the mapping is fairly trivial in terms of, like, you know, lexical similarity or whatever, and putting a score on it. But yeah, I think mapping is just a hard thing to have to deal with, isn't it? And it just takes a lot of kind of decisions, and it's a hard thing to codify, that it's to make it reusable.
Yeah, and I do think one role we have as biocurators is to, when we do team up with machine learning groups, like when we work with biomappings, is to give them the feedback, to go through the data sets and actually identify where things are, you know, fuzzy matches, close matches, the ones that are very hard to do. I think it's nice that we can have that communication. I know we have about 10 minutes left in the session. It went by really fast. Great conversations, but I wanted to see if the audience members had some questions, just to make sure we hear from everyone before we have to wrap up. Anyone want to raise their hand, have a particular question or challenge they've dealt with biocuration and machine learning? No burning questions? Yeah, go right ahead, yep. If you do, raise your hand, please.
So I don't have I will let you take your question before I say anything.
Okay, so we've discussed a little bit about, because you had mentioned building knowledge graphs, right? And obviously everybody's familiar with Google search and their knowledge network that they've built around special cards and things, which is why you get those nice little prompts with connected ideas and other people, for example, that might be related, which is technically a human curated aspect. So, and the way they do that is obviously by a semi-supervised correction process. And so it makes me think that maybe there's a way to build a tool that allows for all of us to kind of cooperate in this semi-supervised correction process.
Yeah, I think that sounds like a great idea. I don't have any, I don't have any suggestions for how we go about building that tool, because it really depends somewhat on your community and who's going to be involved with that. But I don't know if you, any thoughts?
Yeah, I know there's certainly been community annotation efforts in like specific like disease spheres. Like I can remember some where yeah, you'd have people from the public annotate rare disease case reports. And it's always interesting in those instances to see who does the most annotation, because there's always kind of that nice inflection point of people who have the most time to do the annotations, but also the most domain knowledge. So I don't know, you see a lot from like retired nurses and such. So I wonder sometimes if maybe if you had the combination of a public, easy to access annotation tool and like a real focus on people who kind of fit into that subset of like, okay, here are the people who have the most interest in actually contributing their time, and then you find a way to not make it so you're just, I don't know, wasting their time and abusing their willingness to volunteer it. So yeah, to some degree, yeah, some of these end up being kind of like the same issues you see in a lot of other kind of open source and open annotation communities, I guess. But yeah, I'd love to see that happen. That'd be great.
I mean, and this, I mentioned this also last night, but and this could be probably a horrible idea, but it could be a feature as simple as an up and down vote of a single annotation, right? Like Reddit. And obviously that's very granular, but I think that the population level of curators could potentially weed out the bad things as a result of that ranking system. But that's just an add-on. So it's just food for thought. Now.
Yeah, no, just a couple of things. Yeah, so it's interesting you mentioned stuff like Google using their kind of like knowledge graph to help kind of guide their search and things like that. And I think that is the future in a lot of these areas, combining kind of like knowledge-based methods, kind of using ontologies, using kind of like knowledge graphs that are extracted from all of the beautiful databases that we curate here, and using that in combination with kind of like search technology, language models, and so on. And just I like the upvote downvote thing, but I just also want to point out there's a lot of really successful examples in the audience here of different kind of community engagement models. So I think you're familiar with kind of like the Pond-based project, who have I think a good kind of example of a way of which you can kind of like reach out to your kind of community and involve them more in the kind of like proactively in the curation process. And I think many others here have kind of very good examples of things like that.
Yeah, thank you very much for the nice discussion. So I'm more of the machine learner part of the equation, and a lot of discussion has been done on the subject of continuous learning. So having like the model still being annotated actually, so giving the prediction or giving the results of the model, but at the same time asking the user to score the results. Do you think that's, I mean, it sounds like something that could be really useful for the biocuration community in general?
I mean, it certainly could be. I think that's a great idea, and yeah, I mean, I can't add anything. I think, yeah, we absolutely should have things like that. That's basically what's always on my mind. Continuous learning would be really helpful. I guess the thing is, and this is what I sort of wanted to sort of, in my perspective, a lot of the limitations here in this field are related to funding. Like there was discussion about that previously, and you know, a lot of, as Lynn sort of mentioned at the beginning, a lot of program officers, at least at the NIH, are pushing for, you know, implement machine learning models. But as Cecilia pointed out, it takes a long time to do that. You need somebody with specialized experience, right? So at least what I think we should be discussing here is how do we pressure or really strengthen our voice to communicate more fully to the funders. You know, often when I feel like when we have a discussion with funders, it's often like, I don't want to say anything to, you know, make them upset or anything like that because I want them to fund me, you know. But so I think one discussion that would be really great for us to have as a community is how can we organize ourselves to get the funders on the same page that we're on to see what we see. And I know that's a, you know, a long-term thing that Biocuration has as a goal, and we'll probably be discussing that a lot during the conference. But, you know, I mean, I think a sort of an organized effort for that somehow that someone leads is really a good idea.
Yeah, I think that's a great suggestion. I do think we have time for one more question from the audience, and then we have a wrap-up slide because I want people to go to the next session as well. That's a great question. Please.
Yeah, so my question is, I'm wondering if anyone is aware of an existing ontology for machine learning and validation, because one of the things that we have found is that often it's, you know, it's a lot more than just saying something is positive or negative. It can be much more nuanced than that. And it would be really helpful if when curators are evaluating the output of machine learning, that we're all on the same page about what we define as a positive or particular type of positive.
You go first.
All right, okay. I was just going to echo, like, because we do quite a lot of, like, when we train a new model, we'll have like sessions where we have like multiple curators go through at the same time, and you know, we always have like this idealized headings, like these are the yes, no, or like, I don't know, in between. But actually, you end up with like, you know, adding extra columns, and there's a million different ways you can. Like, what about this scenario? Okay, let's add an extra column. So yeah, I think having that controlled would be super useful.
Yes. But you asked if there was an ontology for kind of like AI. So as it turns out, we do have the AIO, the Artificial Intelligence Ontology. And it's got a lot of the things you might expect, like different neural network architectures, but we're also trying to encompass some of the kind of human aspects of machine learning in here as well. So there's a little kind of like sub-hierarchy of different kinds of bias that you might expect, you know, and maybe we've not thought enough about this kind of evaluation aspect, but we'd love to get that in there. And this is being used as part of the Bridge to AI project that Harry is on as well.
I wish we could keep talking. This is really great. I do want us to have an ongoing conversation with us. So Sue and I very much planned for this to be an ongoing conversation, have a further workshops. We did talk about September 2023. We could do one sooner potentially. Food for thought. The points up on the screen right now are things we thought of even before this meeting that maybe help us continue the conversation. So I think we could enhance this though through that we have it on the Slack channel with ISB for this workshop. I think we should, if you have ideas, please add them there. Maybe we can find an earlier time frame even to start having this conversation. It's very productive. And I think we have a lot of voices, a lot of common ideas where we can certainly move this forward. I very much like to do so. But to wrap up with, Chris is gonna have a point, but I do wanna make sure we thank all of our panelists, both sessions, and give them a round of applause, and then we'll have final comments.
Oh, sorry, I just want to do a quick shameless plug. So if you are interested in large language models,
plugs are loud.
Yeah, try our OntoGPT toolkit. It's got a lot of different tools in there for doing kind of information extraction using ontologies, doing gene set summarization. Harry just had a nice paper, a preprint in archive on it. So OntoGPT, give it a shot.
Maybe you could add it to our channel too, so people can find it after. That'd be super. Yeah, then more people can find it. Yes. So find Sue Bello. She's in the blue shirt here in the front if you need to get into the Slack channel and haven't accessed it yet. And then we'll keep announcing things there and see where we can have our next conversation. And I want to thank you all and a great start to the conference.